Hello everybody and welcome to the stream. Cool. So hopefully everybody is set up and ready to go. Um, had about a half an hour to do so, so I'm gonna go ahead and jump in. So, a little bit about me before we go in any further. There is my email. If you have any questions, feel free to contact me there. Uh, just so you know, the slides for all of this will be posted or are already posted in the About section below, so you can grab those anytime and get this information later. So why am I giving this course? I've jumped around in various engineering disciplines. Started with a bachelor's of science in mechanical engineering, and have about a year of design experience with SolidWorks um, for manufacturing, and then decided to check out software engineering. I fell in love with it, started teaching myself, made the career switch, and now I'm a full-time software engineer. And then, kind of along the way in my journey to train myself in software engineering, I launched an electrical engineering startup, built some circuit boards and that kind of thing. And I've really enjoyed just kind of working in each of the three disciplines and then connecting them all together. And so that's what I hope to bring you in the next few days. So, with each of these workshops, they could be an entire career. Uh, you could spend years learning about just one programming language or about just 3D modeling or just even 3D printing or circuits or whatever. And so the goal is not to uh, cover everything, but just kind of give you a very, very shallow, very broad overview of all the things that go into CAD code and circuitry. And hopefully giving you a map so that you can choose your own adventure. And as we're going, I'm keeping an eye on chat, so if you have any questions, feel free to pop them into Slack, and I'll keep an eye on those. So yeah. And this journey, it will be hard, but it will be worth it. Um, I just kind of look around, excuse me, my desk and my bookshelf, and I have lots of projects that I've finished and completed, and it's very rewarding to learn those kind of things. It's very hard. And so I suggest, kind of as I listed here, is a blog post that I did on learning to learn, kind of taking everything of all the things that I've learned and trying to figure out how I actually learned those things. So I invite you to check out that blog post. Cool. So today, day one, we are doing code. Um, and code comes in many forms. You can have code to build websites, and you can have code to um, build video games. You can have code to do many different things. And code comes in many different languages and many different styles, and there's lots to code. So we're going to focus on the Arduino specifically. So we're going to take all of the things we could learn and do with code and do them just with the Arduino. And we choose the Arduino because it is very popular. It is very easy to get set up and run with. Because it's popular, there's a lot of documentation. You can Google any bug, any issue, anything you want to learn. You'll find super long write-ups, official blog posts, example code, example circuits, example everything. Tons of websites to buy resources for it. Lots of things you might want to attach if you want to attach cameras or SD card readers or sensors for humidity or temperature or whatever. There are tutorials, there are write-ups, there are everything for the Arduino. So that's kind of why Arduino. So what is Arduino? Arduino is basically a device that you can upload code to and connect that code to inputs and outputs. So pressing a button might be an input. I'm actually going to grab some components off of my shelf real quick. we'll switch over to webcam view. Cool. So we have something like this, like we have an LED, and that would be an output. We control this. We can turn it on with some code. We could have oh man, these components are very small, but could have like little buttons. Wow, that's actually very hard to see. But basically, you can press it, and that could be an input in your system. And maybe you could actually write some code to connect the button to the LED so that when you press the button, the LED turns on. And so that part, the circuitry part, we're going to come back to tomorrow. Today we're going to look at just the code, how we write code, how we get it onto the Arduino, and learn the basics of it. And then tomorrow we will take a tackle at circuits. So Joshua asks in chat, so in comparison to a Raspberry Pi, it just controls inputs and outputs, and it's not a mini PC. Yes, that's correct. So Raspberry Pi does not run Linux. Arduino does not run Linux. You just send code to it, and then that code just kind of runs. Whereas with the Raspberry Pi, let me actually just grab something off my shelf. So this is the project I did. I actually have it unscrewed still, so I can know the insides. So just a quick tangent, because not every device is meant for everybody. So this is something I actually include in one of my other classes, so I'm going to throw it in here. So this is a Raspberry Pi. That's the circuit board, and then this side is a screen. So basically, it's a full computer. You can connect keyboards and screens and mice to it and that kind of thing. And I use this as like an information display. Currently not traveling anywhere, so don't really need it, but it used to display the weather and bus time so that I could get to work and plan my wardrobe accordingly. So this is when you need more intensive things like big screens and you want to do keyboards and other kind of stuff, you want to use Raspberry Pi. Raspberry Pi also has this cool feature though, that there's these pins right here which allow you to write code in Raspberry Pi to actually do kind of the same thing that you would with an Arduino. So you can control motors and all that kind of stuff, motors and lights and things with the Raspberry Pi. Just kind of depends on the applications and the projects you want to work on. Ooh. For larger projects, I would also recommend or if you want to go the more route of where you want to have Linux, because at that point you can have a screen, you can type Python and other kind of things. You can write Python to control screens and things like that. Raspberry Pi is the other good big one to start with because it is so popular. So kind of different needs, different problems to solve, kind of overlaps as well. You might actually be able to solve every Arduino problem with the Raspberry Pi. But then it also, anyway, we're not going to go too much into that. But yeah, Raspberry Pi, another great thing to check out. Cool. Yeah, so here is a collection of resources that you can check out. I would invite you to also head over to this blog post. I do cover a lot of different things, where to go, where to find things, where to find help, where to find communities, all that kind of good stuff, to kind of help you on your journey and your next steps. And so these are some of the great communities. Arduino, the people that actually make the board itself, have a website with documentation and great stuff like that, and example tutorials and stuff. SparkFun and Adafruit sell a lot of components, hardware and software stuff that you can use to connect to Arduinos and also Raspberry Pis. If you're feeling rusty on your math, science, and engineering, Khan Academy has a ton of amazing courses. And Tinkercad, which I actually discovered in preparation for this workshop, And I don't have too much experience with it, but from what I've seen so far, it's a great free way to get up and running without having to really invest any money, so you can figure out if you actually enjoy any of this or if you don't want to. Yeah. Cool. So we're going to first kind of walk through how to start thinking about problems. Just kind of how real life problems might actually be written with code, or how we can think about tackling problems. So we'll start with this kind of really simple nightlight idea, like how would one make a nightlight if we had a human doing all of it? And so clearly we don't want a human being the one that actually controls the nightlight, but we'll see how we can kind of take what a human would do, put it into code, and then let the human go off and do other things. So once they write the code, the computer just does it for them. And we actually will build this tomorrow as one of the examples. But today we're going to focus kind of thinking about this mainly in terms of code. So I'm just going to get my drawing space set up, and we will switch over to the drawing. All right. So let's see if I'm ready to draw. All right. So goal. Be a nightlight. All right. So we're going to do kind of a flow diagram. You've probably seen this before. It could kind of be something as simple as like, are we hungry? And then you can have two options. It would either be yes or be no. So if we are hungry, yes, we will eat. You can maybe make this more simple and say, maybe or change it and say make food. And if no, maybe we'll go like watch a TV show. And at this point, maybe we finish watching a TV show. And this is how we're spending our vacation. And we're back up here. So we'll check if we're hungry. If we're not, we'll wait 30 minutes because the TV show is usually 30 minutes, and then we'll come back up here. Whereas here we'll make food, and then we will kind of eat the food. And then we'll come back up here. And this is kind of the initial flow of, or this is what a flow would look like. So you come in, are you hungry? No. Watch TV show, so on. So, I thought that would make a new tab. Okay, we'll delete all that. So that's kind of how we start to think about problems. So if we wanted to make a nightlight, we could have a human checking, is it dark? So we'll say yes. We'll say no. And if it is dark, is the nightlight on? If it's not, or sorry, if it is, we will do nothing. And maybe we'll wait 5 minutes. And then we'll check again. around, and we'll wait 5 minutes. And if it's dark, no, we will do nothing. We'll do this. We'll go boop. And so this is how we'd start to build a Nightlight. And basically, it's just a series of yes or no questions and then a time of waiting. If you were a human, maybe you know that the brightness darkness only changes every so often, so maybe we can actually change this to like 20 minutes. And you can see where we start to set. So we have conditions like yes or no. We have questions we ask. We have branches where things kind of split apart. We have tasks to do. So we sit and wait for 20 minutes. Other tasks to do, turn the light on. You can kind of think of do nothing as also being a task. And so this is how we might break down a problem. Cool. I'm going to get out my notebook real quick because I wanted to jot some notes down as I walk through these lectures. If anyone has any questions, feel free to throw them in the Slack chat. Cool. So that's kind of one example. I didn't mean to actually write this out, but so we'll switch back over to here. We'll just save this. We'll do a new. Cool. Okay, for our next example, we want to do a garden waterer. And so this is actually starting to think about how we might build a project out of what we can do in the Arduino world. And so if we had an automatic water gardener, the parts we would need, we need a motor, like a water motor, a water pump. We need some way to measure the moisture, and we can go out and buy a soil sensor. And we would need a bucket for some water. We need a hose. Kind of mostly other components, and then we need like an Arduino. And really a circuit to make this is actually, or the code to make this is actually super straightforward. So basically what we have to do is we have to check if the soil is dry, we turn on the pump. If the soil is wet, we make sure the pump's off. And that's it. That's all the code that it would take to turn on an automatic water gardener. So we could set, say, is soil dry? That's our first question. Yes or no. And you might start to notice some patterns, how we just kind of have a lot of these branching to yes or no questions, and then we do tasks depending on the answers to those questions. And that's, at least in the realm of Arduino, a lot of what we do. Just a bunch of yes or no questions. We do some things, we do some tasks, and then we wait some time and we do them again. And that's really all like our basic robots are. They're just simple loops that go over and over and over again. All right, so is the soil dry? If it is, we will turn on pump. And then we will come back up. Maybe that's a little bit too far. We'll want to wait maybe like 10 seconds. If the soil is still dry, The pump is already on, so we'll just kind of keep going here. And if the soil is not dry, we'll say turn pump off. And then this will loop back around over here. Whoop. Wait 10 seconds and then just keep looping. That's really all the code we need. So we will come back after we do some basics. We'll actually learn how to transform these diagrams here into some functioning code. Any questions up to this point? Cool. Awesome. So we've actually already talked about a bit about how, so today we're going to use the Arduino as a platform to write our code, but we are not going to connect any sensors, any inputs, any outputs, any circuits, things like that. So we're just going to look at the Arduino itself. Once we set up the Arduino, we'll kind of set it and forget it. We're going to mainly just be focusing on aspects of code today. And we're going to do it within the Arduino environment. Like, we could go and use other tools to write Arduino code, but at that point they're kind of in a different environment and things get a little confusing. And so to simplify things, we'll look at it just within the world, the realm of Arduino. So what is Tinkercad? Tinkercad is a lovely place where you can create circuits, write code, and do it all digitally. The collection of tools that have become available to makers and people who want to learn programming and stuff like that and circuits over the last few years has just become is amazing. And so just it's a great place. You can do it all for free as well. So if you want to tinker around and maybe try out a new circuit before you buy the components, it's a great place to do it. Why not use an Arduino? So for the purposes of everyone being on the same page for today, we're just going to use Tinkercad, but it just about exactly replicates an Arduino. So for basic functionality at least, we can do this all in Tinkercad. We can all do it together, and then tomorrow we'll jump over to the Arduino. For those that don't have one of these kits with Arduino components, you can still do everything that we're going to do tomorrow within Tinkercad. So you'll have the training today to use Tinkercad, and then we can you can do it tomorrow within Tinkercad. Or we'll jump back and forth. We'll do things in both. So let us jump over to, see if there's any other notes here. Cool. All right. Let us jump over to Tinkercad. All right. So here is Tinkercad. For anyone in chat, I'm going to go grab some water real quick, and so I'm just going to jump back to this set of instructions for those in chat that might not have Tinkercad set up. Go do that real quick. By the time I get back with water, you should be ready to go, and I'll be ready to go. And we'll see you in about a minute. If anyone in chat is still getting set up, please drop a message in now. Otherwise, we are going to move forward with Tinkercad. Give about 10 more seconds. If I don't hear anything from anyone, I'm going to go ahead. Cool. Oop. All right, let's go to Tinkercad. All right, so this is Tinkercad. And so I got to this page from the dashboard. So if you just go to tinkercad.com/dashboard, this is where you get logged in. And on the left side, you can actually do a lot of different stuff on here. It looks like you can do 3D modeling, which not quite what we're going to do today, but something you can do as well. You can do circuits, you can write code, and I guess there are tutorials for things that you can do on their site. Yeah, but we're going to use the circuits bit today because this will let us write code and do the circuitry stuff for tomorrow. So we will create a new circuit. And we will get this blank screen. And so mainly the bits of interest for today is on the right side. We will scroll down and we will grab the Arduino. And if we click on it, we bring it in and we click in our main area, we can now, if we use the middle mouse wheel, you can scroll around. If you hold the middle mouse wheel down, you can drag around. And this is our Arduino. It is now a functioning, digitally functioning Arduino that we can connect to. So the other bits, up in the top right, if you hit code, you'll get a code editor. We're going to drag it out so we can see it a bit better. Actually, we really don't need to see the Arduino at all, so we'll drag it out as far as we can. Cool. Awesome. So what you're seeing here, and what we're not really actually going to talk about too much, but just want to make a quick mention of it, because similarly to how Raspberry Pi works for some people and Arduino works for other people, this is a kind of visual programming language called Sketch, and it's out of MIT. And yeah, it's basically so you can drag and drop your code instead of writing line by line. Things like connect together, and you can move them about. I bet this is really good. I believe like you can do everything. Oh. What did I say it was called? Did I say Scratch? I meant to say Scratch. Am I saying Sketch? I'm totally saying Sketch, aren't I? I meant to say Scratch. Yes. So Scratch, you can check it out at scratch.mit.edu. Let's see, if we like look at a featured project, it looks like you can like build video games just with this drag and drop stuff. It looks like this specific implementation of Scratch is more towards Arduino, but oh, that's very loud. Yeah, so it looks like you can create full games out of Scratch. Josh asks, are we using the block code or the text code? We'll be using the text code. So I just wanted to give a little tangent to this, because this might be something that helps some people, but I think to unleash the full power of the Arduino, you really need to start writing code. Yeah, no problem. Cool. All right. So if this is of interest to you, I bet you can probably come over to Google and get full write-ups and tutorials and stuff on Scratch. could be a good way to just kind of ease into writing code because it kind of is very visual. So like set the LED on the Arduino, high means on, wait 1 second, low means off, wait 1 second. So it'll kind of, you end up with like a blinking LED. And this is a bit more easy to reason about for people just getting into programming. So it could be worth it to check out. Might be more user-friendly for error messages and things like that. But yeah, so on to code. So if we click this button up here with code, we will switch over. Oh, just kidding, not that one. Right, sorry. In the drop-down, we're going to switch from blocks. I'm actually curious what blocks and text looks like. Ah, okay. So it looks like you can also see, oh, interesting. You can drag things around here and see how they change with code over on the other side. So maybe this could be a nice stepping point to go from code to, or from blocks to text. But we're going to go just straight over to text. We're going to get a little warning because things are going to get a little chaotic now, a little bit harder, but that's where we want to be. So we're going to hit continue. And now we have a text editor. See if I can make that big enough for, cool, that looks pretty legible. Awesome. So this is where we write our code. When you create a new project, this is what it looks like. So just to prove, so we'll open up the Arduino app, and we'll look a little bit more at this Arduino software tomorrow, but when you come in and create a new thing, this is all you get. It's basically 2 blocks to put your stuff, the setup and the loop, and we'll go into all this in a little bit. Cool. So, switching back over to the slides real quick. All right, so we're going to go through kind of one by one the bits of basics of C++. Don't expect to understand any of this like completely today. Software engineering is a hard discipline to get into, and so identify the things that you might need to work on here, and you can go out and buy books and watch videos and do all that great stuff about these kind of things. So these are the basics of C++ that we'll be covering. Types, variables, comments, and functions, and maybe a little bit more of logic and things along the way. Yes, so the 2 parts of every program are the setup and the loop. And kind of what their names say, if we come back to our sketch before of the soil sensor, we can think the setup, or the automatic water gardener, we can think of this kind of bit on the right side as the setup and the loop. So the setup will not be so important for today. That's more of where you go to do your kind of Arduino specific stuff about connecting to circuits. So in your initial setup, you'll say that like Arduino is connected to a motor and it's connected to a soil sensor, and we only need to say that once. Like we're not gonna have to say that every single time. Like nowhere in this loop here does it say set up soil sensor, set up pump. But we do notice here is we have what we're looking at in this block is a loop. Like this here is a loop. We have paths through the loop, so we can go like this and come up, and you can start to see that there's a loop developing here, or we could have a loop that goes like this. It's actually really only the 2 ways to loop through this code here, but we always end up in a looping fashion. We could actually even start kind of doing like figure 8s where we're going through one path and then through the other. And so everything, all the code that we write related to looping goes into the loop block. And I was thinking back to when I first looked at this kind of setup here. Setup's a bad word. When I first started writing Arduino code and I got to this point where I was like, wow, it's really just your initial setup and then you just loop forever. And Surprisingly, every robot out there is really just a loop. Uh, it's just a set of instructions. It's a set of paths, and you just loop, and that's it. And that's all of it. So that's a weird way of thinking, but a good way to start thinking about these kind of problems is they're just loops. So, since we're looking at this here, setup and loop are what are known as functions. So if we think back to, if we jump over here real quick, so a function is basically just a thing that is a set of instructions. I don't know why I'm writing out the word functions. Function is a set of instructions with a name. So it can take inputs, and then it can give you an output. So if we had a function add, Joshua says, so like a method. Yes, yeah. So we notice here we have parentheses and then curlies. So we come back over here, we do like parentheses and curlies. This is the structure of our functions. And in here, let's do some arrows. We have our inputs, so the thing we give to our function. And then here is where we write our code to do what the function says. And at the end, we give out a value, or what we return a value, so that we can use that value somewhere else in our function. So if we wanted a function that added two numbers, actually, we'll come back to our add function. Let's jump into a few other bits. So one of the things we like are comments. And comments are written with 2 slashes, forward slashes. And they are just kind of human readable notes. So maybe something in our code is confusing and we want to convey that so we can remind ourselves if we come back to it. We could write those in comments. The computer doesn't read them. The computer ignores them completely. And so say you made a really complicated bit of code that you thought was very confusing. Comments are a way to be like, to break it down line by line or step by step, however you want to break your code apart. And yeah, so those are comments. We had these idea of primitives, and we're going to do primitives, and then we're going to go back to our add function. So primitives are kind of like our building blocks for doing things with code. And the primitives are basically types of data. And so we can think of types of data as like 5. Like 5 could be a type of data, or we could have the message hello, or we could have a collection of numbers. These are all different types of data. We can have another type of data, like numbers with decimal places. And we won't go too much into why the difference between 3.14, I mean, besides the fact that they're actually different numbers, that's a bit more complicated math stuff and programming stuff, which we won't go into today. But we can think of 5 as is called, Joshua asks, so byte and string and long are primitives. Yes. So 5 would be an integer. We'll come back to kind of parts of your question. We're going to only try and cover the more basic primitives today. and then go into, or we're going to cover the more basic primitives today because they're the only ones that we're actually going to need for our other examples today and tomorrow. But they're going to be a whole long conversation about all the different types for C++, because that's actually the language we are talking about right now is C++. But if we go and look at the primitive types, we'll take a little tangent real quick. Yes. So these are all the types of C++. And so we're only going to talk about integers and Booleans and floating points, but there's all these other ones, and then functions are also one, and some other stuff. We'll get out of there. Cool. So we come back here. So 5 is what is known as an integer. So that's just kind of what we remember from math class. 1, 2, 3, 4, 5, 6, 7, all integers. 0, -1, also integers. In contrast, we have down here floats, which are numbers with decimal places, and they're kind of represented differently in programming. So just good to know that there are integers and there are floats. Hello is a string, and strings are usually denoted with double quotes, like that. And then this list of things is called an array. So just a collection of different, an array is a collection of integers, strings, floats, whatever. Sorry, I got an itchy nose. So as we talked about, we can also grab this add function up here, which is a function. And then lastly, we have Booleans, which are true and false. And so if we think back to our original, let's see if I can actually just, where did I save that image? It's in pictures, okay. So when we come back here, we actually can start to see sorry, just trying to make sure this is all kind of legible. Let's see, let's go like that. Cool, okay. So this main bit right here, as we talked about, is like a loop. And that is, if we go back to our, right here, we can see that loop looks kind of like a function. Well, did not mean to minimize that. Got a lot of windows open. Okay, cool. So we have the loop, so that is a function. We are seeing integers where we're waiting for 10 seconds, and so that's like a value we'll want to use in our function. We have Booleans, so like true or false. We can think of yes or no as true or false. Booleans are just kind of yes or no questions, yes or no values. And then we can also think of functions as like a, so as I said, functions are like a set of instructions. So like turn the pump on, there might be some complicated stuff there, and so we might want to put that into a function so that when we use the function turn on, we don't need to think about kind of what's happening on the inside. And then the opposite of turn on would be turn off, and so we'd have some functions, and so that'd kind of be what this might start to look like. Excuse me. Any questions up to this point? We've got about 10 minutes left, and then we're going to take a quick 10-minute break. I'll be sticking around to answer any other questions that y'all might have. So, if there are no questions, looks like there are no questions. All right, so let's continue on. Cool. So we're going to see how we can use a collection of those primitives. So we're going to use the quotes that we talked about. So one way to write a quotes is with 2 slashes. The other way, if you want to do multi-lines, is you do a slash and then a star and then a slash and then a star, and then you can type whatever in here, and you can see that it's brown, and this whole block will not be seen by the computer. Likewise, you could go like this and write multi-line comments as well, but just for simplicity's sake, we're going to write like this. So we are going to create code for a nightlight. And so if we remember our primitives, 5 is an integer, also known as int. That's kind of the short code that we use for it. 3, let's go with 3, sorry, 5.1 would be a float. Hello. We're actually not even going to use strings in this one. We're going to want Booleans, so true, false are Booleans, which I don't actually remember. I think it's bool. Yes. I know that because I can see, it might be hard to tell, but so text editors, and this is what we're seeing on the right, it's where you type your code in, will sometimes change colors to specify different things. And so I can see that it's changing to purple, specifying that it knows that it's a float. That's something you'll just kind of pick up as you start to write more code. That surprisingly doesn't light up. Okay. Okay, so true lights up, which means that this is actually lowercase, not uppercase. Quick little tangent there. So you'll notice that the true here on line 9 is with a capital T, and it is black in text. And then on line 8 with a lowercase t, it is blue. And programming is all case sensitive. So just as a little bit, jumping a little ahead here, but start simulation will run the code that you have, and you see that nothing really interesting happens because it's still like the initial code that we wrote. If we do something like true, I believe this should work. Oh no. Okay, so true can't go there. Let's see. Joshua asks, are there any languages that are not case sensitive? Probably. I think it's dangerous to of the most popular languages in the world, no. I in my code hold on, let me just finish this part and then I'll come back to your question actually, because I like your question. So we'll talk about this syntax later, but basically it runs and we're fine because we use the correct form of true. Whereas now we're going to get an error saying true was not declared. And that's just something you'll notice. So case matters is basically the point I'm trying to get at. So back to Joshua's question. When I do coding, case, you can use case to represent different things. So we like to use foo a lot to mean just kind of like a placeholder or for an example. So this might be code. This is kind of very confusing. Or just maybe to demonstrate that there's so much programming going on, or so much kind of nested layers here of complexity. But basically, this is different from that, and I know that this is a different type of thing than that. So if we went back to that chart of types that I had searched on Google, Foo would be a class. Undercase foo would be an instance of that class. Valid foos would be a const array. So really just to note there that I used class as one thing, instance of class as another thing, and a valid list of inputs, array of inputs is another thing. And those are denoted by 1 all lowercase, 2 by 1 capital letter, and then the rest lowercase, and then 3 by all capital letters. So case is a useful way to kind of have some, or sorry, having case sensitivity is a good way to kind of distinguish things from each other. Because otherwise this variable, this thing that we're using here might have to be like, this would have to be like class of foo, and this would be instance of foo, and then this would be valid array of foo. And you can see just how like many more characters or letters we're starting to use, and it gets really long and it kind of gets pretty dense. So we use case to kind of add some additional information to our variables, our values that we use in our code. Cool. All right, so I'm going to delete that. Right, we're going to come back here. So we're going to use bools, floats, integers, and we're going to use functions. Excuse me. Okay. So hopefully we've got about 3 minutes left. So hopefully we'll try and get this set up completely, and then we will stop for break. Or we'll cut halfway through. Anyway, okay. So our setup first, and we will, so we'll add a comment. We'll say to do setup for pump and setup for soil sensor. So actually we're going to get into some case sensitivity right now. To answer this first question, is the soil dry? Pretend we have some function, check soil moisture. And this function we'd have to write it out at some point. Let's actually just write it up above. So void check soil moisture, and this will, so this is where we start to create our functions, and this is going to be a fake function, and we'll do to declare these values, like these floats, you first say what kind it is. So this is an int. It is going to be we're returning a whole number, and this will be an int of soil moisture, and this is a value that we're declaring, and this will read, we'll have some sensor set up, and that'll be some function somewhere else, and so we'll have to wire this up. But for now we can just not write out that function, and we'll say we'll make this a function later, and we'll just set it to the value 5. And then here on the next line we'll want to kind of return that value. So the check soil moisture does a set of instructions, gets a final value that it wants to give back to some other part of the code, and so we can just return the soil moisture. I forgot one thing. We need to end every line with a semicolon, and each line is an instruction, and we know that we're at the end of the instruction for that line with a semicolon. And this is what we have. Cool. Okay, we are actually at break. So we will pause here. We will be back in 10 minutes. Yeah. So I'm going to try out real quick if I can't wing my little script that I wrote to set 10-minute timers. So we'll set countdown for 1:05. If we save that and we bring our countdown back up. Do, 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 do. All right, right here. We're zooming in. And if I click on the bit above my face, all right, because we're in the wrong time, so it has to be 13. Okay, so that's a little off. We'll go 10 minutes. All right, so we'll resume in 10 minutes. If you have any questions, feel free to throw them in chat. And, glad to answer them now. If anyone wants to get caught up, I'll stick around and answer questions. Yeah. we're going to go ahead and get ourselves started again. Hide our timer, bring my face back. Cool. Any last minute questions from break, things you were thinking about related to what we're doing, what we're not? As long as it's related to code, happy to answer. Or the larger picture, also happy to answer that. Before we dive back in and finish writing our water gardening function. Cool. All right. So I actually realized I was just thinking about our check soil moisture function, and maybe we want to add a comment here that says this function will return a value between 0 and 100. Well, instead of a value, we'll call it an integer. Between 0 and 100, where 0 means, actually let's change this to a multi-line comment. And we'll close it on the other side. So this function will return an integer between 0 and 100, where 0 means a desert, super dry, and 100 means entirely water. So if we dropped this soil moisture sensor into a bucket of water, it would read 100. If we took it out to the desert and stuck it in the sand, we'd probably get 0. And then for the rest of the world, we'll probably get values somewhere in between 0 and 100. So for now, we're just going to have it return 5, but made a note that we'll make this a function. We'll make this return, we'll pretend we'll make this return something else later. So we added some comments. Maybe we'll put it inside the function so it's a little bit more legible. We'll indent so we can read it. Don't want to save it, didn't mean to do that. Cool. So we've added a nice little comment for our check soil moisture function. And maybe, actually we'll leave that be for now. So back to our point about casing, capital, lowercase, and that kind of thing. Say we want to have an integer that is our, say we want our garden to always be 20% water. I don't know if that's a good number or not. These numbers you need to figure out in real life. Maybe you like some plants, they want it to be 1% water all the time. Other plants, like a plant that lives in a lake, probably wants 100% water. So we'll say that we have some plants that want, we'll say a water threshold, a moisture, soil moisture threshold. And we're using all caps to declare what we call a constant. It is something that will never change. And so we'll set that at 20 and say we always want our soil moisture to be at least 20%. And if we go back to our graphic, this kind of gives this number 20 we put in here gives a more logical, like, is soil dry? For a human, that's easy. You touch the soil if it's, you can kind of tell by touching it. But a computer needs a little bit more of a very concrete set of instructions. So is soil dry will be whether the soil moisture is greater or less than 20%. So we will continue on to our loop. And we will take our check soil function, soil moisture function, and this returns an integer. And this void bit here, which I didn't talk about before, is the value, the type that gets returned from the function. So right here, we're returning soil moisture, and it is an integer. So we will say that check soil moisture returns an int. So then we will create a new variable because we'll want to capture that value that we returned from our function and store that. And we can call that current soil moisture. So that's the first step. We need to check, to answer the question, is the soil dry, we need to know the moisture of it. So now that we have the moisture, we can do this little branching logic, the yes or no question. And we can go, and we do that with what are called if-else statements. And if-else statements are, we'll check conditions. And this is where we get the branch. So if our condition is true, we'll go one way. If our condition is false, we'll go the other way. So what we want to do here is we want to turn the pump on. If the answer is yes, we want to turn the pump off. If the answer is no. So we write this with parentheses, and you can actually sneak comments in. Actually, we won't sneak a comment in. We'll just do this. So if current soil moisture is greater than our soil moisture threshold, this will mean that the soil, we want greater than or equal to. And if you think back to basics of math, you can do all these kind of symbols. So you can do, we'll do some comments. You can do greater than, you can do less than, greater than, equal. If I can spell, you can do exactly equal. We can do not equal. Actually, I forgot how to do not equal. Yeah, so this is, I had talked before, Arduino.cc, great reference, not equal, and it tells you all about, compares the variable on the left with the value on the right, and returns true when the two sides are not equal. So, yeah, something to know. And can always throw these things into Google if you don't know how to find them or to look them up. Cool. So that's not equal to, and so we specifically want to see if the current soil moisture, is greater than or equal to the threshold. And if it is, why did you indent like that? Oh, I think the issue is I forgot a semicolon here. Remember, you need to close every line like this with a semicolon. Okay. So here, we'll do a little comment for that we want to turn the pump off. And we'll come back and we'll finish that out. And so these curly braces here denote that this is the code that will run if the if condition is true. Else, which will be the opposite, if the if condition is false. Cool. So we'll just leave our comments in there for now. So I noticed a little simplification we can actually make here. In that I don't know how exactly to explain it. But basically, really what we want to do if the soil is dry, if it's not dry, we want to do nothing. And if it is dry, we really just want to turn the pump on for 10 seconds, turn the pump on, wait 10 seconds, and then turn it off. And then we can check again our if condition. And so this will actually simplify because we can get rid of this whole no branch. And so we don't need the else block anymore. And we could just create a function that says turn on pump And we can give it a value of how long we want it to run for. So this is where we can start to give different instructions. So right here we want to turn the pump on for 10 seconds. Maybe turn on pump is not the best name. Maybe we want to call it like water garden. And so if we come up here to where our check soil moisture function is, we'll call water garden. And this function doesn't give us back any values. It just waters the garden for 10 seconds and then it stops. So type that here. And this is where we begin to use what are in the parentheses. And the parentheses are a set of instructions that we can pass to water garden to make it do something slightly different. So we'll come back to how we do that. First, we'll just have a turn on pump function, which we'll pretend we get from somewhere else. And then we'll have a delay function, which will run for, let's look up the documentation for delay real quick. So delay, the description of delay, pauses the program for the amount of time in milliseconds. And as a note, there are 1,000 milliseconds in a second. And we use it by typing delay, parens, with the number of milliseconds to pause. So for example, if we come down here and look at, we're kind of seeing that similar structure of void setup and void loop. And we won't talk about this line, but basically what it does is it runs this instruction, waits 1 second, and you can see even they love to throw in helpful comments. So this is why I love Arduino.cc for their documentation. Do another instruction, wait 1 second, and then loop and start over again. So that's the delay function. And so if we wanted to delay for 10 seconds, 10 seconds times 1,000 is the value that we want. And we can do basic arithmetic. I mean, we can do any arithmetic in programming. But let's look at the documentation for math real quick. Cool. So this walks through kind of the basic set of instructions that you can do in programming. So you can do like plus, you can do minus, you can do times, and you can do division. Again, Arduino.cc has lovely documentation on this. So we could just do, so we could put that value in here, but that's kind of like hard to read. You're like, wait, where's the, how do you do the what? And I even put the wrong number in there because 10 times 1,000, you count the number of zeros, and anyway, so there should be 4 zeros, so I did it wrong. So instead, to make this kind of more easy, and when you're writing code, it's always 90% of your time is spent reading your code. You spend so much more time reading code than you do writing it. So trying to just make things easier on yourself. So if I wrote 10 times 1,000 here instead, that's kind of much more easy to reason about because I know that delay takes milliseconds. So this stands for converting to milliseconds, and this is the number of seconds. So this is how we'd water our garden for 10 seconds. And there's a little gotcha here. I'm not sure if you can notice if this function is complete or not, but it is not. So delay itself just sets a break. It just says we're going to wait for 10 seconds. But if we didn't do anything else with this function, the pump would just stay on. It would just go forever. And this is a gotcha, I think, that like, so if we have our loop, and it'll come through here and say the soil is dry. So we check our current soil moisture, and then we do our comparison, and it waters the garden for 10 seconds. And then the loop starts over again, but the pump's still on. So maybe then now the garden is fully watered, and we get in here, and this returns false, so we don't water the garden anymore. But the pump is still going because we never turned the pump off. We turned it on, but we never turned it off. So always make sure that you have your next bit, which is another function that we pretend we get from somewhere else, which we'll talk more about actually connecting these things to pumps and that kind of stuff tomorrow. But for today, we're not going to worry too much about the circuits or at all. So that's that. So programming is all about reusability. And say we wanted to take we accidentally killed our plant, not because of watering. We definitely wrote a perfect watering garden script, but say we killed it because we forgot something with the sunlight. So sunlight killed our plant instead. And so we went out and we bought a new plant, and it needed to be watered with a different value or a different number of seconds. A different number of seconds per whatever. We could come in and instead of just calling water garden, we could give it a value. So maybe we want to water our garden for 5 seconds at a time. So we can pass in this 5, and when we use water garden, if we come back up, in these parens, we can say that we'll declare a new variable and call it duration. And instead of 10, we can do duration. And so this 5 will get passed into water garden, will be called duration, and then we can pass it in here, and now we can delay for 5,000 milliseconds, 5 times 1,000 milliseconds. And this should be everything we need. And if I wrote this all correctly, I can hit Start Simulation. I think it should work. Oh, we got some errors. Oh, right, because we didn't define these functions. Okay. I know how we're going to actually fake this and make this a lot easier. If anyone has any questions up to this point, I'm going to take a quick sip of water, quick sip of my coffee, and then we'll continue on. But if anything about this doesn't make sense, please let me know, and I'd be happy to answer any of your questions. All right, looks like we have no questions. So similarly to how we talked about passing in values, we'll actually come back to that in a quick second. So we'll have we'll have turn on pump. And a turn off pump. And this will actually be our first dabble into our setup function. So one of the cool things we can do in specifically Arduino land is we can use this thing called serial. And serial is a way for us to so it's a quick little thing. Just grabbing out my Arduino. So when you plug in the Arduino to your computer, you have this one side, which you should all know as USB. The other side goes to serial. And so we can plug that in to our Arduino. And if we actually look, let's switch back over to the screen. If we look on the screen, you can see that it kind of pretends to do that little connection there. And when we hit Start Simulation, you'll see that besides the fact that we have errors in our code, it'll connect itself in to say that the simulation is running or not. I thought that was pretty funny. So when we hit kind of Start Simulation, or when we upload code to the Arduino, the code kind of just lives in here and it runs. And if we want to get data or feedback back out, you'll notice that nowhere in here do we actually say anything back. So if we need to troubleshoot, if we need to debug, if we just want to see how often our garden gets dry, we won't be able to get any of that information back. And so what we can actually do is we can use what's called serial communication, and we can talk to our Arduino. So we do serial.begin. Actually, let's not go that far. So basically, begin is a function. Serial is a collection of functions. And you'll see that we can start to do other things with that. And then we set up with 9600. And you don't really need to know so much about 9600 besides the fact that it's the rate at which data gets transferred back and forth between the Arduino and Raspberry Pi. So the lower the value, the slower it is. So if you set serial.begin to be slow or lower, it could be as if I'm talking this slow. Whereas if you set it higher, it could be that I'm speaking really fast to you. You're getting a lot of data at once. And 9600 is usually the standard that people put for it for most things. Yes, you'll see here 9600. So the data rate is 9600. I think it's bytes per second. So I'm not going to go too much into 9600. You can ignore that pretty much. So we begin serial, and now we can use the other things that hang off of, or that come bundled with serial. So we can print. LN stands for line. So I'll show you kind of the difference between that and print line. So if I type in hello here, and this is where our first instance of string. And string is just a collection of letters and numbers and periods and other, it's just kind of like human readable text. Whereas 9600 here would be an integer because it doesn't have quotes. You could also do a string, but then serial would be complain. I bet if I run this, it'll say expected. Yeah. Not going to go too much into this error, but going from a char to an int, a character to an int, can't do that. Won't talk too much about that now, but can do this. And if I hit start simulation, we're up and we're running, and then we can come down to this lovely little button down at the bottom of the serial monitor. And if we click the serial monitor, we can actually see that message. This is kind of hard to all think about because it's all just in your browser. But basically what happens when we hit start simulation is it pretends to upload the code to the Arduino. And then this is actually the serial monitor is monitoring data coming back from the Arduino. And we can type down here and we can send stuff to the Arduino. Since we didn't write code or do anything with it, it just goes into the void and disappears. So we will close our serial monitor. If I can find the close button. There we go. Cool. Okay. So if we move this into the loop, we can start to see the looping awesomeness. So we'll start our simulation. We'll come to serial monitor. Oh, I put the wrong thing in there. And we can start simulation. And you'll notice, woo, 1, it keeps putting it in the same line, and 2, it's going very, very fast. So the first thing is that the difference between print and print line is that print line will kind of like hit the enter key on the keyboard. So if we add print line and we run that again, we can come here and see now it's going straight down instead of horizontally across, so it's easier to read. And then also, it's moving too fast. So remember that delay function that we had learned about up here? If we come over here and do delay of this, we'll see that it's 1,000 milliseconds times it'll delay for 1 second. If we run this, if we clear this out, you'll see that now it's a lot slower. So that's the joy of always adding in delays. Delays help kind of slow things down. Cool. So now that we've talked about serial.print, we will come back here to print. So this will just be like a placeholder, and you could imagine that we could, instead of having it print out a message, we could actually write some code down here to go and talk to the pump and turn it on, but we're not going to do that today. So yeah, so for right now, as we had mentioned, check soil moisture. Let's see. So let's walk through the process here. So if we start simulation, we'll clear this out, and we'll see that nothing's happening. And so now we're going to kind of step through and maybe give ourselves some debugging to kind of help us out. So first, I'm wondering, is this thing even running? So I can be like serial.begin or serial.print line. This is how I debug all the time. I am working. And then maybe we'll throw a delay of 1 second in there. And if we start simulation now, we'll see that I am indeed working and it is looping. So we'll come back here, stop our simulation. All right, so what's happening? What is our current soil moisture? So we can then do serial.print line, print out our value, start simulation again, and we'll see that our value is 5. We're like, okay, something's happening here. So maybe we'll stop our simulation. We'll take this print line, and instead we'll move it into here. And this time we'll say my garden is dry. We'll start this. And then we'll kind of notice that we're never actually getting into this if block of code that we have here, because this condition in here is never true. And the only way we get into the block is if the condition is true. So maybe as a next step, we get an else case that says serial.print line, my garden is watered. And we'll start. Sorry, it seems like your code has some errors. In function void loop, so in void loop, error, okay. So these are some helpful instructions. It says line 50, so we come down to 50, at column 41, so I'm not going to count 41, but it looks like it's probably all the way at the end. Expected a parentheses before the semicolon. That's actually pretty helpful. So it looks like we are missing a closing parentheses. So this is the opening parentheses. We'll close it out. We will start our simulation again. And we'll see that our garden is properly watered. So there's only so much faking we can do in this code, so we're about to abandon this example altogether, or call it complete. But maybe we can come back into our function where we were faking the soil moisture. Oh, there's actually some issues in our logic. Funny. So we wanted the soil moisture percent to be 20. We wanted 20% moisture in our soil. This function is returning 5. So this logic should actually be the other way around. So this is saying, because we take our values, this is 5, this is 20. 5 is not greater than or equal to 20, so my garden is watered. But actually, we want to switch this logic and make sure. Actually, there's 2 different ways to flip this, and I think that we can either take these and flip them, so we can move this over here. So if the soil moisture threshold is greater than or equal to the current soil moisture, we will water the garden. Or we could flip the code in the box that says, just put this one up here, put this other one down below. and that would do the same thing. And I think this reads, I go for legibility and things that make sense, and I want to make sure that my current soil moisture, to think about, I think it makes sense that we're always greater than the threshold. That's what we're aiming to achieve. And then we'll say, yay, our garden is watered, else womp, our garden is dry, we need to water it. So now, if we start our serial monitor, we'll say, my garden is dry, we're turning the pump on, and we're going to wait 10 seconds, and then we're going to turn it off. So that is what this code is doing. So we'll take this code, I will paste it into Slack. If y'all want to copy it into your editor and play around with it yourself. Are there any questions up to this point? Cool. All right. So, let's switch back over to here. We got, let's jump ahead to this problem. And I'll give you about 10 minutes to take a crack at this. And so the goal is to output the numbers from 0 to 100. So we want them to display in our serial monitor. One bit I haven't told you about yet is I++. So you'll need to go to Google and figure out that. But otherwise, this should be everything you need to solve that problem. If you have any questions, I will be around in chat. So it is 1:39 right now. We'll circle back around at 1:49, and then I will solve the problem and answer any other questions. So I'll reply only in chat so I don't distract people with my voice, but we will regroup in about 10 minutes. All right, so let's see if we can't diagnose Joss's issue in chat real quick. So I think what's happening, and I'm going to come back in. And for those that don't see, it looks like there's an error. And just for me personally, you get good at kind of with experience reading through error messages like this. So if you want to copy and paste your code into chat, I could bring it up on the screen, or I could just kind of try and recreate the issue that you're having on my own. Okay, so reading through this, it looks like check soil moisture, return statement with the value in function, returning void loop. So it looks like void value not ignored as it ought to be. So by chance, do you have just the word return written in your loop? Because I believe, so 5 is an integer. We said that loop would return nothing, so void, like the word void meaning nothing. So if we run this, I think we might actually get, we'll delete all this other code as well. Return statement with a value and function returning void. So I think this is more or less or is an error similar to this. So loop and setup specifically never return values. You could also get a similar thing with if we write this and we return vive, an integer within my test function, and then if we call it, yeah, similarly return statement with a value, because we're saying that we're returning void. So instead, if we change it to be the proper return type, so my test function returns an integer, I can start it and everything is happy. And kind of I figured that out by looking through the issue and kind of feeling like void value not ignored as it ought to be was something I could take to Google. And when you take these kind of messages to Google, generally want to throw quotes around them, which will exactly match that. So you'll find other people posting the same issues. So I peeked through the first 2 links. And kind of this one, these are a bit hard to read because Arduino kind of gives you a helpful set of tools on top of just C++. And so this is a C++ answer. So sometimes when I Google these things, I like to do quotes for the exact error message and then throw an Arduino at the beginning so I can kind of get something else, which will bring me to like the arduino.cc forums. And the code will probably look a little bit more like what we want. Ah, cool. So he typed void instead of int and got it working. I usually skim until I see something that looks like an answer. But yeah, the more experience you get, you can kind of skim these kind of discussions. Keep poking through. This one has marked solved, so maybe we'll come read this one as well. You could probably skim through. Oh man, there's a lot of code. Yeah, so I guess this will kind of be helpful. You can kind of think about it in terms of your code. It says, does the read method, and it would be the read method here, does that return a value? If it doesn't, then you can't pass that value on to something else. So that's just a little quick tangent into addressing errors. So let's go back and let's solve. Whoop, totally went to the next screen. Let's do this. Okay. So our new challenge will be a line break this so it's a little bit more legible. Cool. This is our goal. Output the numbers from 0 to 100 over and over again on the screen. So if we look at this, we'll see that the number's from 0 to 100, so we'll need an int, some kind of counter of sorts. We'll need to use our loop function, because we'll want to keep going over and over and over again. And then at some point, we need to reset. And I don't know what that'll look like. So, and also we need the last bit, output the numbers to the screen. So we'll probably want to use serial. So, let's serial.begin. And we will have a counter, and we'll make it to 0. And then we will increase the counter by 1. So this is some syntax that you haven't seen before. Basically what it's saying is take the current value of counter, add 1 to it, and then this value will be saved into counter. So if counter is 5, before it gets here, it'll do 5 plus 1 is 6, and 6 will become the new counter value. And the next time it comes back around, counter is 6, it'll add 1, and it'll keep going. Cool. And last thing we want to do is serial.println what the counter is. So if we start our simulation, come to the serial monitor, it's always 1. All right, so why would that be? And so one way I like to troubleshoot these kind of things is it's always nice to, Joshua asks, could you do counter equals plus 1? It looks like yes. We still have the same bug, but we could do that. One even other shorter notation, because programmers are lazy and they like to be even, they like shortcuts wherever possible, is you can do plus plus, which will also keeps recreating our same bug. So let's figure out this bug first before we look at these things. Okay, so what's happening? So let's write some comments. All right, so we're coming into our loop. Our counter is 0. We are adding 1 to our counter, so our counter equals 1. We are printing out 1, and then we get to the end of the loop, so we'll go again. And oh look, we're setting counter equal to 0 again. So this is always going to repeat. We're going to print 1. Or sorry, counter will equal 1. We'll print 1. And clearly, this is overriding everything. So this shouldn't live inside our loop. So how can we solve that? So it looks like we'll want to keep track of this int outside of the loop function so that the loop can get access to it but doesn't override it each time. So if we move it here, and we do this, and we run this, let's see what happens. Cool. We have a counter. But oh man, it's past 100. So we're going to need to do something about that. So actually, now that we have that working, we can come back and look at our shorthand notation. Let's start this. How does this look? Yep, does the same thing. Cool. And then we could also look at, what was it, equal plus 1. Just lots of different ways to do things, so just something to keep in mind. Okay, so it actually looks like the answer to your question was no. Interesting. Oh, let's learn something new. Okay, but that does work. All right, so let's go learn about that. Plus equal versus equal plus C++. Here you go. Let's see. We got a lovely little demo. The plus equal is the compound assignment operator. symbols equal plus are two operators, the assignment operator and the plus operator. So I guess it just has no effect. Oh, interesting. Okay, so this is the bug. It looks like plus equals is, so this is the syntax that is short for counter equals counter plus 1. Whereas the other way around, equals plus, just says that counter is equal to positive 1. Whereas similarly, we could do counter is equal to negative 1, and that would just get it stuck at negative 1. Whereas if we wanted to do it the other way around, if we wanted to subtract 1 each time, we do minus equals. There you go. Interesting. So a little gotcha for the day. Kind of fascinating. Okay. So let's get our shorthand back. Make sure we're back to a working state. We are. I like to incrementally check my code as I go, to make sure things are still working. So let's see. If counter, so we'll want to do an if block. So if counter equals 100, we'll just set its value to 0. All right. So let's start this again and see what happens. Oh, that is moving very fast. All right, let's slow this down so we can see it slightly better. Let's add in a little delay. We're going to go in milliseconds this time. So 50 milliseconds is 0.055% of a second. So not too fast, not too slow. I think that should, yeah, it's a good enough value to read. And we're going to stop simulation when we get at 100. Cool. So we get all the way up to 100. And oh, look, we don't start at 0, though. What is that about? All right, so we can come back through. Again, we're going to do some of that, the little thought exercise here. So our counter starts at 0. That's cool. So counter starts at 0. And it comes in here. It's not equal to 100, so we keep going. We add 1 to it, and then we print out 1. So we can already see the issue here. Counter plus plus will never let the value 0 get printed out. So if we swap these two lines, we should print out 0 first, and then it gets to 1. And it comes back through, and it's 2, and we can keep going. And so now what happens when it gets to like 99? So I like to just explore these kind of what-if scenarios. So 99 comes through. It's not equal to 100. We will print out 99. We will increase the counter. We will come back to the beginning. The counter is equal to 100. And so we will reset the counter. And then we'll print out 0. So it looks like now we have an issue on the other end of how to print out 100. So there's a few different ways we can solve this, but basically what we can do here is if the counter goes past 100, then we'll want to reset it. So at 101, so now if we look at this code, we start at 100, we start at 99. 99 is not greater than 100, so we keep going. We print out 99. We increase to 100. Counter is still less than 100, so we print out 100. We increase it to 101, and now 101 is greater than 100. We reset it, come back through, reset it to 0, print out 0, and now we should be good to go. So let's delete our comments, start our simulation. Get ready to stop it when it gets up to 100. Perfect. 97, 98, 99, 100, 0, 1, 2, 3. And now we have ourselves a thing that'll count to 100. So yeah, so like, what could we actually do with this kind of information? So there's a type of motor called a servo. Sorry, not a servo, a stepper motor. That was a silly thing to search for. We want a stepper motor. Cool. All right, so this is a stepper motor. And a stepper motor, basically, by its name, it can step. One step at a time for a full rotation. So if we come back here, so we have our little stepper motor, and it has a shaft that comes up. And it maybe has a little rotating wheel. I'm terrible at drawing, but maybe that's our wheel. That's not so bad. And so the stepper motor, you can say, you can pass it, maybe has a step function, and you can pass it a value, and it'll step to that value. So stepper motors typically have 200 steps. Would E1 full rotation. So if we wanted to go like 180 degrees, so 360 is a full rotation. So we go back to geometry. If we have a circle, we have 0, we have 90, we have 180, 270, and back to beginning is 0, or 360. So if we wanted to go half rotation, to get to 180 degrees, we'd go 100 steps. And so to go here, be 100 steps. So instead of this 2, we'd pass in 100, and we'd step to 100. And if we wanted to have a motor that would step through each of the one step at a time, we could say in our little, what did I just do? In here, we could say if counter is greater than 200, because most steppers have, or servos have 200 steps, and instead of printing out, we could do step, and we could step to the, instead of counter, we could call it like current step. And then we could kind of, every 50 milliseconds, rotate a motor by 1 step. And so that could be just a use case of this kind of stuff. Hello, Hellcat. Welcome to chat. We are actually just wrapping up, unfortunately, for now. I think we got through most of what we wanted to get through today, so I don't think we'll be returning this afternoon. But we'll be throwing this recording up onto YouTube as soon as it finishes getting compiled, so that should be hopefully within a few hours. We're finishing with some homework, so if you want to step in and do some homework, you're welcome to. Yeah, womp womp. Sorry about that. Cool. So this is how we'd increment the numbers from 0 to 100. Let's switch back over. Cool. So we've run out of time. We're actually about 21 seconds left at the timer. If y'all want to check out the slides, they are in the description down below. Yeah, so check out the slides. There's a little feedback survey in there. If you could fill it out, it'd be greatly appreciated. I will be hanging around Slack. I'm probably going to go make lunch. Can I post the code in Slack? Yes. Cool. So yeah, so gosh, a whole collection of things I want to say. Let's switch over webcam. Cool. So I got a feedback form that I appreciate if you filled out. Just trying to get better at doing this teaching and that kind of thing. If you look down below, there are links to social media, so I invite you to follow me there. And if you enjoyed what you saw today, toss me a follow here on Twitch. Trying to work towards Twitch affiliate and other stuff so I can do this more full time. Maybe get paid to do it at some point in the future. So I'll be sticking around for the next few hours. I might start a stream where I'm working on some personal projects related to CAD code and circuits as well. And I'll also keep an eye on the social media, or sorry, on Slack. So we will have office hours and homework kind of now for the next few hours. So I've written up some homework, and yeah, I'll give you some help if you want to try and get through them. So tips, join on Slack if you haven't already. The link is actually down below. And just get comfortable with Googling your questions. So when you get stuck trying to think of different ways to Google things, and it's kind of an ability that, it's kind of this long-running joke that anyone can Google programming questions on the internet, but it's how do you pick the right question and the right answer to solve the problems you have. So that's a super solid skill that even now I am on Google multiple times a day looking things up. You don't need to keep it all up here. Take notes, know how to search, and you'll be fine. So here are the problems, problems 1, 2, and 3, and I will also copy these over to Slack. And so they get kind of increasing difficulty. You'll need to poke around the documentation for some of these and learn about different math operators and different functions of serial that we didn't talk about today. So yeah, so these are the homeworks. So that is all for now. If there are any last questions, comments, whatever, feel free to drop them in Slack or in Twitch. Thank you, Hellcat. Cool. Let's go update the calendar. Right, it's on my other account. So I will do that on my own phone. I'm a Twega, can't speak. Gonna do a little be right back, and then I think gonna actually jump into working on my 2D plotter. Hopefully try and get that done. For those that don't know, where do I want to go? Why am I brain? That's what I want. Brain farting. Instagram. This is 2D plotter that I'm working on. I've been streaming every Tuesday. It's designed it, engineered it all from scratch. I'm going to wire it all up and program it with Arduino and C++ and with Python. And so I'm going to design some parts and update them, and probably get the printer running at some point here, and then yeah, so got random things I want to do. Probably make up a little to-do list, get myself organized, and then I'll be back in a bit. So thank y'all again. Check out the problems. If you have any questions, ask in Slack. Otherwise, I will see you same time tomorrow. I think we're going to have a bit more of an in-depth day tomorrow, building on some of the code we did here today, and then we will start connecting up circuits and electronic bits and having fun with that. So cool. Thank you all for attending. Thank you for your questions. And Joshua, thank you especially for keeping me company this entire time and keeping me going in chat. And I will see y'all next time.